Okay, because it a bit. Okay, so we are done with the concept of friction now. We are done with the concept of normal contact force. We are done with the concept of the inclined plane as well. How do you work out forces, break down into the components along the plane and perpendicular plane. The next thing that is important is friction in detail. Friction is dependent on two, three factors, but right now, the friction force that they won't always give us the force of friction. Okay, sometimes they would ask you to find the force of friction and then use it further as well. So, how do you find in situation like that? Is like that we have a formula which is relating the friction force and the normal contact force, and the formula goes in like this: F max is equals to mu r. R, what is R? R is the normal contact force. Mu n or R, it's up to you. But this is the normal contact force, which we know now how to find this out. This mu is the coefficient of friction. Coefficient of friction. This is the new thing. So if we have the normal contact force acting on the object, and if we have the coefficient of friction between the object and the surface, this coefficient of friction is simply a constant. Okay, which can vary question to question. Sometimes you will find it, sometimes the question would give it to you. This is a constant coefficient of friction, and it is always between object and the surface on which the object is what do we say, traveling, moving, and the surface. So for example, this is the surface and this is the object. So they might say that the coefficient of friction between the object and the surface is 0.7. So this can be one of the ways. So this mu can vary question to question. We don't go into the detail how do we determine what is the physics behind the mu. This is just a constant which we will use or we will find, and that's it. That's it. This is the mu. Okay, this is just the coefficient of friction. It refers to the roughness of, you can say, if you have a very rough surface, definitely this mu would be higher. If you have a very smooth surface, then your mu would be very small. Smoother surface, your mu would be small. So if they, for example, in the question they talk about a rough surface, the object is traveling on a rough surface, then this mu would not be equal to 0. Okay, then there would be friction would be present between the surface and the object. So friction is present. But if they if they tell you that the surface is a smooth surface, a smooth surface means that right now we assume that the friction is 0. So the coefficient of friction in this case would be exactly 0, and therefore friction F max would be 0. Okay, this is an important thing. For example, right now, this object, let's suppose this is of 5 kg, they ask you, and the coefficient of friction is given to us 0.7. Find F max that when that can be applied. If the object will go into motion, then the maximum friction that it can apply is that can be exerted. So what do? We need F max is equals to mu r. R would be right now exactly equal to the weight, because right now the object is in equilibrium. So the weight is 5g. So normal contact force would be also 5g, because there is no other force vertical direction. So the friction would be 0.7 times 5 times 10. So this would become 3.5 or 35 Newton. So this calculation is actually giving us the maximum friction that can be between the object and the surface. So this is the maximum friction. Maximum friction. I'll explain to you how. Why am I focusing on this thing. Now this friction, let's suppose this is the same object. Okay, we have the same object, we have the same coefficient of friction. Okay, you have the object, it is of 5 kg. Mu between the surface and the object is 0.7. and there is a force right now which is to the right side. Let's suppose it is of 10 Newton. So tell me if right now the object will move or not, because we know F is equals to ma, right? F net or Fr is equals to ma. So assess the situation right now. Right now, see if the object will move or not move. So right now this would not move, because we know we have right now calculated the maximum friction that can uh, exert between the box and the surface. It was 35 Newton. So right now there was a force to the right side which is of 10 Newton. So in opposing this force, there would be a friction right now of 10 Newton, which would be exactly overcoming that force. So therefore, this would become F net would become 0. 10 minus 10 is equals to ma. So this becomes 0. So therefore, your acceleration would be 0. So your object would not move. Okay. Do you get it or not? Let's suppose you have the same situation and there's a force to the left side. This object is of 5 kg, and now a force of 35 Newton is being applied. And it is the same situation, 0.7 mu. So in this case, again, your object would not move, because right now your friction, the maximum friction that can be applied, F max was 35. And this 35 Newton friction can now be exerted between the object and the surface to the other side in such a way that again 35 minus 35 would become 0. So again you get an acceleration of 0. So object would not move. Do you get this thing? For example, there's a very, very big car, okay, or a truck. If you try to push that truck and you are not able to push it, definitely you are forcing the truck to move. But because there is a friction between the tires of the truck and the what do you say, the road, you are not able to push it. Your force is not enough. The friction is greater. The friction that can be applied maximum is greater than the force that you can apply. So even though you are applying the force, it is causing no effect. This is the same case, same situation right now. Now let's suppose if it is a car. In your car, when you start pushing it initially, let's suppose this is a car, there is definitely a force of, there is the weight of the car, and there is a force, a coefficient of friction between the tires of the car and the surface and the road. So initially when you start pushing the car, you slowly increase your force. Let's suppose the F max between the car and the road is, let's suppose, 100 Newton. So initially you start pushing it with 10 Newton. So friction would oppose it easily. The car would not move. You try to push it harder. Let's suppose you force it with a 20 Newton force. So the friction would be now 20 Newton force, because again friction can oppose this 20 Newton as well. So let's suppose I also help you out now. So now my and your force combined, now it is equals to 80 Newton. We are pushing the car with the force of 80 Newton to the right side, but still the force of friction is greater. The maximum friction that can be applied is 100. But right now, overcoming the 80 Newton force which we are together applying on the car, they are being cancelled out and the car is not moving. Let's suppose another person also comes in, Nadia. So all three of us are now pushing the car, and now the force is equaling exactly 100. Is still, what would happen? The car would not move, because right now the friction is being overcome by the force. Still the resultant force is 0. Then after this, let's suppose one more person comes in, Murtaza comes in, or someone else. Now the force is, combined force of us is 110. But the friction cannot be increased now further. Friction maximum is 100. So now you will get a resultant force of 10 Newton to the right side. And because of this resultant force, the car would start to accelerate in the right side. Do you get this example? This is the friction. So as long as you are pushing something less than the force, maximum force of friction. The friction is exactly the same as the force. And then there comes a time that you are exactly equaling out the maximum friction. This situation, when your force is exactly equal to the maximum friction that can be applied, this situation is called a limiting equilibrium. Slightly, let's suppose I give it a slightly force 101 Newton, that would also cause the car to move because now it is overcoming the force of friction. So exactly when your force and the friction are equaling each other out, this is limiting equilibrium. The object is equilibrium, but it can move at any second if your force slightly increases as well. If by 0.1 or 0.01, if your force increases, the friction cannot further increase. The maximum friction is now being applied, so you would get a resultant force, and because of that resultant force, your object would start to move. Do you get it? Okay. Nadia, Nuba.
Yes, sir.
Yes, sir.
So this was the first case, that the force that I am applying is less than the force of friction, maximum force of friction. So the F friction force, F friction would be equal to the force. And second case, when your force is exactly equal to the force of maximum friction, this is limiting equilibrium. And the third one is when your force is greater than the force of friction, maximum force of friction. In this one, your car or the object would start to move. Let's suppose now it is you are pushing it with 50 Newton force, but the friction is maximum friction that can be applied. We have calculated it to be 35. So what happens now? You will get a resultant force, and because of that resultant force, you will get acceleration. So resultant is 50 minus 35 is equals to 5 times a. So 15 is equals to 15 divided by 5 is equals to a. So the acceleration is coming out as 3 meter per second square. Right now, the 5 kg object would start to move with 3 meter per second square. So these are the three cases that you will see in the past papers as well when you do the questions. These are the things that can happen when friction is involved. If friction is not involved, then it is the easiest part. Then you don't have to consider the friction anyway. Your friction would be zero, your mu would be zero, everything would be zero. Okay, Nadia, Noba, Ammaz clear?
Yes, sir, clear.
Hmm. Good. Copy these down. These notes are important. Limiting equilibrium is more. You'll see very good questions from limiting equilibrium. Most of the questions are very repetitive, very easy, but there are some which will open your eyes. Okay. Okay. Let's do a question. Okay, so now a lot of things can now combine all together. Forces, F is equals to ma, friction, everything. So let's suppose this is a situation, is the surface. Okay, this is an object of, this is right now I'm making question of my own, so maybe the values that you get may not be very reasonable. I don't know. I try to make the question as reasonable as possible. And there is a force like this, which is 70 Newton at an angle of 30 degrees. Okay. And the coefficient of friction between block and surface is point point 4. Let's suppose 0.4. Find acceleration of the particle. If there is an acceleration, we'll find it. If applicable या क्या बोलेंगे? If क्या बोलेंगे? Okay, let's see. I don't have the correct word. So first of all, we have to right now break it down to all of the forces. So we have the weight component, which would be 6 times g, which is 10, and the horizontal component, which is pushing it to the right side, it would be 70 cos 30, and vertically upward it would be 70 sine 30. Okay, the component opposite to the angle is sine, component adjacent to the angle is cos. Upwards would be normal contact force, and because there is a force which is pulling it to the right side, so the force of friction would be to the left side, because force of friction would always be opposing the force which is actually trying to cause the motion. So F max on the left side. So if you form the equation, sum of forces equals to MA. So you have 70 cos 30, which is trying to pull it to the right side, minus F max, which is trying to pull it to the, which is trying to stop it, is equals to MA, 6 times A. Now to find the F max, it is equals to mu R, mu N or mu R, it's up to you. So mu is 0.4. We have to find N. So if you want to find N, we have to work through the vertical forces. Sum of vertical forces is equal to 0 because the object is not moving up and down. So vertically, the object is at equilibrium. The object is not moving up and down. So this would be what? Vertically upwards, you have N plus 70 sine 30 is equals to, this would be how much? Down you have 60. So N would be 60 minus 35, which would be 25. So the normal contact force is 25 Newton. So now you can replace it over here. So F max would be equal to 0.4 times 25, which would be equal to how much? 4 over 10, 100 over 10. So 10 Newton. 10 Newton is the maximum friction that can, what do we say? That can stop the force, which is causing the motion. So now F max can be replaced with 10 Newton. This is 70 cos 30 is equals to 6A. So now you can find the value of A. So look, everything is now interconnected. 70 cos 30 minus 10, and this thing divided by 6. So the acceleration of this object is 8.44 meter per second square. 0.4 times 25 is 10. Okay, this is the final answer. Okay, any questions? Anyone?
No.
No questions. Okay. A little bit interesting if we make it. Let's suppose the second part is saying find mu if the object is accelerating at let's suppose 2.1 meter per second square. Okay, so now the situation is slightly changed. We don't know the value of mu, we don't know the value of F max, we know the other forces. Okay, so they're asking us to find the mu if the object is accelerating at this 2.1. So F is equals to ma. Mass is again 6. Acceleration, we now know it is 2.1. The force, horizontal force, which is pulling the object is 70 cos 30 minus the force of friction can be opened up into mu R. So mu R, or the normal contact force, N we already know it is 25. So mu times 25. So that's it. So what would we do? We would 70 cos 30 minus 6 times 2.1. So this is giving me 48.021 is equals to 25 mu. So mu comes out to be 1.92. 1.92. 1. So this is the value of mu if the object was now accelerating at 2.1 meter per second. Do you get it? So this is how the questions can move things around. If they give you something, they ask you for another thing. But the basic concept is the same. You try to equate all of the forces together as equals to ma if the object is moving. Okay. Hmm. Okay, let's suppose it is of 2 kg and there's a force to the left side. Let's suppose it is of 14 Newton. Okay. And the coefficient of friction, let's suppose I don't know. Mm-hmm. It is 0.2. Okay. 0.2. Okay, let's change it slightly. It is we don't know coefficient of friction. There's another force which is acting like this. So this is of 50 and this angle is 60 Newton. Oh, sorry, 60 degrees. Find the mu, the coefficient of friction between the object and the surface, if the object is in limiting equilibrium. Limiting equilibrium, or it can say just on the verge of moving to the left. Moving to the left. Okay. Limiting equilibrium, I told you that the force which is trying to cause the motion, it is being exactly overcome by the force of friction. If the force which is trying to exert, trying to cause the motion is slightly higher, the object will start to move. Right now, they have told us that this object is on the verge of moving to the left. So this means the object is just on the verge of limiting equilibrium, so it would move on the left. If slightly, you have another force on the left. So definitely, if you think about it, the friction right now would be acting on the left side, sorry, right side, because the object is on the verge of moving to the left. So the sum of forces before the friction is trying to move to the left, but the friction is stopping it to move in the left side. Okay, so if you break it down, the other forces as well, this would be 50 cos 60, and this would be 50 sin 60. Weight would be 20 times g. So normal contact force would be, we don't know, we will find that out, and we need to find the mu as well. Okay, so everything is now known. Whatever the forces that we wanted to find out, they are now here. So we know now sum of forces is equals to ma, but because this is on the verge of moving on the left, or it is in the limiting equilibrium, the resultant force is 0. Okay, so how many forces are horizontally? There is a force of 40 Newton which is pushing it to the left side, and there any other force on the left side? No other force on the left side. So there are two forces on the right side, which is 50 cos 60 plus the force of friction, F max. Now, how would you find the F max? We have to use the mu n or mu r. And for this, n would be equal to, you have to find n somehow. So vertical sum of forces would be 0. So vertically upwards, there are 2, n plus 50 sine 60 is equals to 20. I think I will have to change the question slightly. I have to increase the mass. Let's suppose the force, sorry, this is now 50 or 5, or let's suppose it's 4. So the weight would be 4g. Okay. So, okay. Now we can see the downward force is 40. 4g, 4 times g. So the normal contact force would be 40 minus 50 sine 60. So use your calculator, find the normal contact force. 40 minus 50 sine 60. Again, I'll have to change it slightly. The mass should be 5. Let's do it 5 kg. Sorry, this is my own question, so slightly sometimes it becomes 50 minus 50 sine 60. This is coming out as the normal contact force is now coming out as 6.699 Newton. Okay, so now you can replace the n over here. So F max would be equal to mu times 6.699. 40 and 50 cos 60. So 50 cos 60, when it goes on the other side, goes and subtracts. So 50 cos 60 would be 25, I think. Cos 60 times 50. 25, 40 minus 25. 15. So 15 is equals to 6.699 mu. So mu comes out as 15 divided by 6.699. So 2.24. This is the value of mu. This is a very high coefficient of friction. The coefficient of friction values that you would see in the past paper or the questions that you would do later, it would range from between 0 and 1. Maximum, I think, 1 or 2, it would be above 1. Okay. This is a very high value of coefficient of friction. This is how the question goes. Okay. Any questions over here? This is a question for limit equilibrium. This is how you would do. The resultant force is 0 when it is limit equilibrium. And the direction of the limit equilibrium, it was right now on the left side. So the friction, we kept it on the right side. Because the object was on the verge of moving to the left. So friction is on the right side, which is stopping it to move it to the left.
Wait, sir, I have a doubt.
G.
When is the mu 0.7 or a constant value?
When is mu 0.7?
Yes.
When is why 0.7?
Oh, didn't you say it wasn't constant?
Constant मतलब सवाल के हिसाब से constant होता है. If you have a particular type of object and a particular type of surface, so the coefficient of friction between them would be a constant. If you have a different surface, definitely it won't have the same smoothness. मतलब
Okay, so
उस साइड का वो उस तरीके का constant नहीं. I get your question. I might have stated it wrong. You are right about it. It's not like a pi constant नहीं है. It is constant according to the situation.
okay, sir.
Okay, let's do another one. Last. Okay. 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 I hope the question is all right because I made it myself again. So let me think if it is, if I have to make some changes. I think it's good. Okay. So if we right now we don't have the mass, so definitely there would be a weight component which is pulling it down, which would be what would it be? What is the weight component?
mg cos theta.
Sine.
Oh yes, it was.
Sine. Sine is for the what along the plane, and this one was mg cos 22. And definitely there is no other force which is perpendicular to the plane. So the weight component into the plane would be cancelled out by the normal contact force, right? So right now in this situation, the normal contact force is equal to the weight component into the plane. Okay, and we right now know that the acceleration is down the plane. It is 1.5. So if we do the F is equals to ma, we take positive down the plane. Okay, so whatever the things which are pulling it down, keep them positive. So the weight component is pulling it down mg sine 22. And anything else? No, there's no other thing which is pulling it down. If it is going down, definitely the friction would be upwards, opposing the motion. So minus F max and minus the 20 Newton force, which is also going up the plane, is equals to m times acceleration, which is 1.5. Okay. Now F max can be opened up into mu n. So mu is 0.5 and n is mg cos 22. Mu n minus 20 mg sine 22 is equals to m times 1.5. So now look, this is your complete equation. This is your complete equation. So you move things around, bring all of the m's together. If you bring the m and take it common, so this becomes g sine 22 minus 0.5 g cos 22 and minus 1.5 is equals to 20. If I have made the question correct, if I, which looks like right now, otherwise the whole question would, I'll have to change the values. So g sine 22 would be 10 sine 22 minus 0.5 times 10 cos 22. My question is wrong. Let's, I'll have to change the question. I'll have to change it should not be negative. It should come out as positive. Let's suppose this force is also down the plane. Okay. Okay, let's change it like this. The force which is pulling it, it is also down. Sorry. 20 Newton. So this would become positive. Now you will get the right answer. So this becomes positive. This is also pulling it down, pulling it down. So this becomes negative. Okay, everything else is the same. Just I have changed the direction of the 20 Newton force. Okay, now if you solve this, minus 1.5, this is giving you negative 2.289 m is equals to minus 20. So mass comes out as this answer, minus 20 divided by this answer. Sorry, minus 20 divided by this answer. So 8.37. This is the mass of this block, kg. Do you get it? Look at the situation and the direction of the forces which I have put in over here, and the F max direction, and how I calculate the F max as well. Okay. If there's any questions, ask. Otherwise, copy it down properly. Try to understand it. Do this again. Let's stop the recording. That is it for today's class. Hopefully, in the next class, we'll do some past papers according of these things. Stopping the recording.